Arlington Passivhaus project. We're southern exposure homes. We're working with Passivhaus Architecture and IntelliStructures. They are two of our most important partners. Where's page that? Our history. We are a real estate developing company. We started with basically purchasing and flipping houses, and we always had this interest in green buildings. So we tried to do some green flips until one year that we bought a house that was so ugly we could not renovate. So we built a brand new house that was kind of green because we put in tankless water heaters, high efficiency furnace. But you know, if somebody would ask me how green is it, really, couldn't really tell you. So you know, we had a great time, but then we thought, you know, we need to do better. So we wanted to be able to quantify exactly how green we are. So we started searching for a performance-based standard. So why do we build green as a developer? We believe that green isn't simply about materials and finishes. As the green movement matures, I think consumers will start caring more about energy efficiency, indoor air quality, design, and function. These are standards that people will start demanding. And we believe that because very few production builders are willing to take the risk, there is demand out there. And so we are ready to take the plunge and fulfill that demand. But to do that well, we build one house at a time, because we want to dedicate ourselves to building it to the highest standards possible. And you know, our grand vision is to help the way Americans live one house at a time. So why Passivhaus? David, you know, explained to you the different reasons that he's attracted to it. The way we are attracted to it is, first of all, you know, it takes about six to 10 months to construct a house typically. But once the house is built, it's good for 50 to 100 years, depending on the quality of construction. So which one is more important, the process of building it? Are you using, you know, where are you shipping your lumber from? What kind of finishes are you using? Those are great sustainable goals. But for us, I think the more important thing is the 50 to 100 years that people are living in it in terms of energy performance. And then because this is a performance-based standard, we can, using the PHPP software, we're able to predict exactly, because it's such, you can design everything to such a granular level that you're able to predict exactly how much energy is going to be used by the house. And beyond those few energy standards, your design flexibility is almost infinite, because you could build any shape you want. You just need to make sure it performs within certain limitations, of course. But that's the way it is with every house. Scalability to larger buildings. We're interested in infill projects, turning apartment buildings into passive buildings. I think this is very beneficial to landlords and also to affordable housing. So you can do any type of building with this. Commercial buildings, there is a school in Charlottesville that's being built to the Passivhaus standard. There is a 30-unit apartment building in Philly being built to the Passivhaus standard. So you can do it with any type of construction, suitable for all income levels. We have, you know, multi-million-dollar homes. If you're going to put in that much money into a house, why not make it energy efficient? In terms of low income, an example would be Habitat Humanity in DC. They're building an 11-unit townhouse community using Passivhaus approach. And finally, we're just very attracted to the idea of using less, because we don't need very much. We need less. So why waste? You know. So this is a chart from the Lawrence Berkeley National Laboratory. Basically tells you how much average American household uses in terms of pays an annual energy bill, approximately $2,200. And if you look at the breakdown, 29% goes to heating, 17% goes to cooling. That together is 46% of your energy bill. And that translates to, based on that 2,200 number, you pay basically about $1,012 a year. So there are two ways to heat and cool the house. David explained to you how passive house works, and I'm just going to sort of reiterate a little bit. Conventional building, when you build it, you assume you build a standard thermal envelope, which walls are about R13. Our house, we're actually built into R40. And you assume the house is leaky, and you use the cracks to ventilate the house. But the problem with that is, as time goes on, there's mold, there are different issues to your walls that develop. So, in a way, the air you're breathing is not very, very clean through those walls. So somebody in Passive House actually told me that's like breathing through your underwear. And I agree with that. Next, you install ductwork in conditioned areas. I mean, have you ever wondered, does it make sense to shoot cool air up to your unconditioned attic to cool your room? That makes no sense to me. But that's how the houses have been built in the past 20, 30 years. And those ducts are very leaky. They never tested, they never really sealed it correctly. So with all of those problems, leaky house, inefficient ductworks, you have to operate your equipment unnecessarily because you have so much heat loss. And then next, for the HVAC contractor, when they design your system, to make sure that you're comfortable, they will oversize your system. So all that over-engineering contributes to that 46% of energy cost. Now, on this side, we have Passive House. The assumptions are completely different. You start with a robust thermal envelope. You have very thick insulation, air tightness standards, very, very high air tightness standards, and you use an ERV to ventilate, so you're no longer breathing through your underwear. And then you install a ductwork. The ductwork you install is all in conditioned areas, so there's no heat loss, and you make it airtight. And then you operate equipment only when necessary, because there's so little heat loss, you only need to do it during the very extreme days of the year. And because the load is so tiny, you can properly size your system. You don't need to over-engineer it. So now we turn to about $101 a year. So, there's your savings right there. And this is just on a sort of an average house. Now, Passive House, the difference between Passive House and the regular house, really, these are the two main differences, the thermal envelope and the HVAC system. Just to give you an idea of what we're building in Arlington, we have really good windows, U value of 0.11 and solar heat gain coefficient of 0.61. The solar heat gain basically allows us to turn all the sun's energy into heat when we need it in the winter time. But we will shade it during the summertime to prevent heat gain. So, and we have a really tight construction at 0.6 ACH, really thick insulation, R40 walls and R60 roof. HVAC system, we're using ERV to ventilate, and that one, the efficiency for that is up to 95% recovery rate. We also have a very small heating and cooling equipment. David's system is a little bit more complicated than ours. All we're using is that it's that mini split system. It's a reversible mini split, so you can heat and cool at this, with the same machine. It's only a 1.5 ton unit. Literally, it's about this big, and it will heat the entire house. Let's see. And we have we're gonna end up with very small utility bills. So what does it mean for the person who lives in it? There is constantly ventilated fresh air. So you have a much higher air quality. There's no draft like David described. No temperature stratification. You don't need to have multiple HVAC systems. It's all going to feel the same way in the entire house. It's also oriented to take advantage of sunlight. So you'll be bright, and you also can take advantage of the heat energy. Now, what else? Beyond Passive House, the Arlington house we're building, we are using precast concrete walls and SIP panels to minimize on-site construction waste. Both of these things are panelized and basically built in a factory, and they just truck them in and install it, assemble it. So there's no waste. And then we have green roof above the garage. That's going to help reduce stormwater runoff, as well as creates a sort of a semi-public space for people to gather. We're using low VOC wood flooring and cabinets and no VOC interior paint. And there's going to be fly ash in the concrete foundation to increase the strength of the concrete and reduce Portland cement content. We're using fiber mesh in the concrete, so we don't have to use as much steel rebars. And also it prevents cracking. For the house, for the lighting, we're using CFLs and LEDs to light the entire house. And the garage, because we're building this house for the future, we're going to wire it for electric cars, as well as creating a roof that is ready for solar panels and solar hot water if they want to. Low flow plumbing, of course, and then the way the house is built, there is the garage is actually structurally isolated from the rest of the house. The benefit of that is you will have cleaner indoor air because exhaust fumes won't come into the house from the car. And also there's no penetration into the thermal envelope of the house. And then we're using permeable pavers and rain barrels to reduce stormwater runoff. And basically these are very cheap ways to sort of be environmental and build sustainably. So that's about it. That's for me. So.